everyone, and welcome to today's section of our class. Today we are going to be having class in mathematics, and you are all welcome to this tutorial. And today we will be the first time shooting a class. We are going to be discussing on the number system. Now, in this number systems, we have so many different number systems. We have the base 2 number system, we have the base 5 number system, we have the base 8 number system, we have the base 16 number system. And the most commonly used is the base 2, base 10 number system. So, the base 10 number system is generally our normal numbers in which we use. This comprises of numbers from 1 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then back to 0. So in our base 10 number system, that is a decimal number system, it only comprises of only 10 numbers. It starts from 0. When it reaches 9, it completes the 10 decimal system. Let's count 0 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are our base 10. So when it reaches 9, it repeats itself and starts again from 0. Now when it reaches 9 and it starts from 0, that means it has completed a bunch. One complete bunch in the base 10 system forms what? The 10. Do we all understand? So, this is the base 10 number system. Another number system we want to discuss is called the binary number system. Now, the binary number system consists of only 2 numbers, that is the zeros and the 1. And now, basically, those kind of number are being used in our everyday computer. Our phone network, our phones use the binary number system. Our computer system uses the binary number system. It consists of only 2 numbers, that is either 0 or 1. So, if this is the base 10 number system, the binary number system, which is called the base 2, is only zeros and 1. Okay. That means if it is zeros and 1, that means you cannot have any number that is 2. You cannot write 2. 2, you have to convert 2 into a binary number. Is that understood? Alright, now another number system we want to discuss is the octal number system. Octal number system. The octal number system is also known as what? Base 8. From the word octagon. We know octagon is gotten from the 8-sided polygon. So octal number system is also called a base 8 number system. As the name implies, base 8. So that means you cannot have any number 8. You can only have numbers from 0 to 7. Then from 0 to 7 forms one bunch. When you go count from 0, 1, 2, 3, 4, 5, 6, 7 completes the 8 numbers. So let's have it 0, 1, 2, 3, 4, 5, 6, and 7. You count 1, 2, 3, 4, 5, 6, 7, 8. You can see that we have 8 numbers there. This forms our complete base 8 number system. So if you have any number that is given to you, now your result appears to be 8. You have to convert the 8 into base 8. You understand? Alright, the next thing we need to discuss is the hexadecimal number system. Hexadecimal number system. Hexadecimal. Hexadecimal number system. Another name for this number system is called the 16 number system. So, if the base 10 is called decimal, Decimal is base 10, and then hexa means what? 6. It's also from the word and from the 6-sided polygon, which is what? Hexa. So hexa means 6. So hexa, which is 6, plus decimal, which is 10, makes it what? 16. So the hexadecimal number system is also called the 16 number system. So in case that means if you have numbers extending from 0 to 10, exceeding 10 to 15, that is the hexadecimal number system. It's comprised of numbers from 0 to 15. That means when we observe, when from 0 to 9, that means it has completed the 10 number system, right? So it moves from after 9, your 10, 11, 12, 13, 14, that means the system repeats itself into another bunch. It tries to form another bunch of numbers. But this time around, we are going to show, I'm going to draw a table, and then I'll show you a general table for this number system. Let's have a table, number system, numbers, then number, let's have base 2, base 2, base 8, and base 8 is our next number, base 10, and then base 16. So we're going to have different numbers, and then we'll see what each number means. So when it is 0, base 2 is what? 0, base 8 0, base 10 0, base 16 0. Now before I proceed, base 8 number system consists of numbers in 3 bits. When I mean 3 bits, you have 3 digits number. 3 digits number. That is the base 8. When n, you have n, 2 raised to the power of n. 2 raised to the power of n. 2 raised to the power of n. If it is in base 8, that means base 8, n will be what? 3. So you are going to have 8 here. You understand? So for base 16, you are going to have 4 digit number. 4 digit is 2 raised to the power of 4. 2 raised to the power of 4 is 16. So that tells us that whenever numbers are given to you in base 8, the numbers are going to be in 3 digits. If it is in base 16, the numbers are going to be in 4 digits. But when we look at base 10, those numbers in base 10, in base 2, are mostly not affected. So for base 2, let's say we have 4 digits, or let's say we have 4 digit number because of base 16 here. Here we're going to have 1, 2, 3. Then we have 1, 2, 3, 1, 2, 3. So when we have 1, what are we going to have in base 2? 0, 0, 0, 1. This is all for base 2. Then in base 8, the number continues 1. Base 10, 0, 0, 0, 1. Base 16 also 0, 0, 0, 1. Let's continue. When it is 2, here we don't have 2 in base 10. So in base 2, sorry. So instead, if we are having 2, so for the sake of understanding, so that we will not confuse, so that you will not be confused, let's just have 0, and then let's have 1 here. Just the last bit here. So when it is 2, it's just like when you observe, you add 1 here, you have 1. You add 1 to 0, you have 1. You add 1 here, you have 1. You add 1, you have 1. So when it is base 2, you add 1 to 1. Generally, it's supposed to be what? 2. Then you cannot have 2 in base 2. You cannot have 2. That means in base 2 it's supposed to be 0, 1. Then the next number is not going to be 2. It's supposed to be what? 0 again. When it goes to 1, it has completed the first bunch. So the next bunch will be what? 0, 1 again, making it what? 2 bunch. Next one will be what? 0, 1 again, making it 3 bunch. So this one now, when it goes to 0, 1, it has completed the first bunch. So this one becomes 1. The next 0 makes it what? 10. Can you see that? Makes it 10, which is 1 and 0. Do you understand? Makes it 1 and 0. Here was 0 and 1. This one becomes what? 1 and 0. Do you understand? Then the next one becomes what? 1 and 1. Do you understand? So then this one becomes what? 10. Because it has completed the first one, 0, 1, completed the first one, which is 1. We start again, 0. Understand? So this one now becomes what? The same thing, 0, 1, 0. That is, this bit appears all through. 0, 1, 0, 0, 1, 0. 0, 0, 1, 0. This one becomes 0, 0, 1, 0. Now, when it is 3, what happens? You add 1 here. Now, remember, it was first bunch and 0. This one what? First bunch and 1. You keep adding 1 to the last bit. This one becomes 0, 1, 1. Then this one becomes 0, 0, 1, 1. Same here. 1, 1. Now, you can see, what do we observe? We observe that the last bit of the last digit of the number, adding 1 changes the numbers, right? So when we proceed, we will keep seeing changes. What are these changes? If you add 1 to this one, remember, this is 11. Just like saying 1 and 1. This one has completed what? Successfully completed 2 what? 2 what? Bunches, right? 2 bunches in what sense? 1 and 1. This is the first bunch, it has completed the second one, so it must go back to what? Another bunch. When it goes back to another bunch, what does it become? This one becomes what? If you add 1 to this one, it becomes what? 10. So this one becomes 0 and 1, right? The 1 goes to this one. You add 1 again to this one, becomes what? 10. So this one becomes 100. This one, same thing, as you have 100 here, you're going to have 100 here. You're going to have 0, 100 here. And then lastly, 0, 100 here. You see, the number is changing. Now, first of all, we started from 1 bit, you see 1, then to 2 digits. From 2 digits now, that's the completed a bunch, we change to 3 digits. You see, after the first and second, change again, completed a bunch. First one, second, completed. Now we 3 digits now. So now let's continue. Let's keep adding 1. If you continue adding 1, what does it become? This will become 1, 0, 1. 1 to the last digit, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. Now 6, add 1 again to the last digit. This one becomes, if you add 1 here, it becomes 10. So you have 1, 1, 0, 1, 1, 0. Here is what? 0, 1, 1, 0, 0, 1, 1, 0. Is that what we have? Yes, that's what we have. So, what about 7? 7, what happens? What happens? Add 1 to this last bit. 1, 1, 1, 1, 1, 1. 1, this one becomes 0, 1, 1, 1, 0, 1, 1, 1. Is it interesting? Very, very interesting. So let's keep going. Because when we are solving questions regarding binary numbers, we need to take note of all these things. If not, we will make mistake. So now when you add 1 to this one, it becomes what? Remember, if you add 1 to 1 here, it becomes 10, 0. Carry 1. The 1 that you carry, you put it here, add it to this one, becomes 10 again, 0. Carry 1. 1, the same thing happens here, 0. Carry 1. So you now have 1000. So the same thing goes here. Yes. 1000. Affects everything. That's now changed. We have the 4-digit number. Add 1 again to the last bit. 1001, 1001, 1001, 1001. All through. Now when you have 10 here, what do you have? Now we can see that the numbers fall from what? 0 to 7. Let's start again. From 0 to 1, we have 1. That's completed for binary. When you have 2 and 3, you can see the digits will change in the fourth one, meaning you are moving to a what? A next bit, right? To 3 bit number. That is this, right? Then we when we got to 7, that was the last one. So it changes from the second, the fourth, the 8th, everything changed, right? So in the 10th one, let's continue, add 1, 1, 0, 1, 0, 1, 0, 1, 0. So it continues like that. You keep adding 1, keep adding 1, keep adding 1 until you finally get to our 16, 13, 14, 15. Remember, we started from 0. So we 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 16. So wherever we have 1 all through, then we stop. So here we're going to have what? Remember, if this is 1, 1, the next one is supposed to be 100, just like we had here. This is 0, 1, 0, 1, 1. What do you have is 1, 1. You see 1, 1. When it is 1, 1, you add 1 again. So here we're going to have 100, 1, 100, 1, 100, 1, 100. We continue adding 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1. Continuously 1, 1. We add 1 to this one, becomes 10. Now, adding 1 becomes what? So, we can now stop. So, now, when we are discussing number system, binary number stops here. Numbers that falls from in base 3. Base 3, we cannot have 3. Base 3 number system can only stop in 2. Right? It stops here. This is base 3. Base 4, base 5, base 6, base 7, base 8, base 9, base 10, 11, 12, continuously up to base 16. So then in base 16 number system, we must take note of something. Alphabets are being replaced with number, with where the number 10 falls from. So what are we saying? What am I saying? I'm saying that what we have here, from here, number changes, number system changes. It has completed a full bond for decimal number. So in base 16, this is represented with alphabet A, B, C, D, E, and then F. So don't be surprised when you see a number system given to you in alphabet form. Those alphabet stands for a particular value, a particular number in the number system. So now, if this is the number system, this is the general table for the number system. Now, let's look at addition of this general number system. We can convert from binary number into decimal number system. We can convert from binary number into hexadecimal number system. We can convert from binary number into octal number system. And also, we can also reverse the case, converting from either hexadecimal to decimal, hexadecimal to binary, hexadecimal to octal number system. There are steps in which we must follow, and we need to be very, very careful in solving each and every thing. Now, look at something. We have our timetable, our times table. Our times table from 1 times table, 2 times table, 3 times table, 4 times table, up to 10 times table. Generally, when we look at the normal times table is 1 times 2, which is 2, 2 times 2, which is what, 4, 2 times 3, which is what, 6. These are number systems in base 10. When we look at 2 times 4, which is what, 8. 2 times 5, which is what, 10. How does it become 10? This means that 2 times 5 means what? This has undergone what? A complete bunch and 0. When we go to 2 times 6, what happens? Let's observe. 2 times 6. 2 times 6. How did you get 12? How did you get 12? Remember, in base 10 number system, we cannot have what? We cannot have what? 10. The number ranges from 0 to 9. When it's 0 to 9, it has completed. That is 0 to 9 completes one bunch. The next thing you will have will be what? 1 and 0, right? You have another one with 1 and 1, 1 and 2, 1 and 3, like that. So, In other words, other number system, you cannot have that number. If you have base 2, you cannot have 2 as a number. Base 4, 4 as a number. No. Base 5, 5 as a number. You have to convert it into decimal form. So the same thing here. When adding, when subtracting, when multiplying, and when dividing, we must take note of a particular thing. In base 10, when you are adding a particular number, let's say 56 plus 56. This is a number in base 10. 6 plus 6 is 12. Right? 6 plus 6 is 12. Now, in base 10 number system, what do we do? First of all, you cannot write 12. What do you write? First of all, how many 10? Since it's a decimal number system in base 10, how many 10 can go into 12? How many 10 do you have in 12? You see that we have just 1 10 plus ordinary 2 numbers. So first, remember, we must always write down the remainder. You only write down the remainder and take the value of the bunch of number to the next number system. What does it mean? So if 6 plus 6 is 12, how many 10 do we have in 12? We have 1 10 and 2. Remember is the 2. So we write down the 2 and take the 1 10 there. So 5 plus 5 is 10. 10 plus 1 make it 11. How many 10 do we have in 11? It's just 1 10 plus 1. So we just have the remainder here, which is just 1. Then we need the 1 10 here. Then 1 10, what are we adding to? Nothing. So we bring it down here. So this is the number in this thing. This is additional number. Now this system is different for other systems. In base 2 number system, if you are adding numbers in base 2, let's say you have 1 1 1 plus 1 1 1. You have 1 plus 1. If this is in base 2, 1 plus 1 is 2. You cannot have 2 in base 10. How many 2 do you have in 2? You have 1. Remember what? 0. You have a 0. Take the 1 here. 1 plus 1, 2 plus 1, 3. How many 2 do you have in 3? How many 2 do you have in 3? Is 1, remainder 1. So you write 1, write the 1 here. 1 plus 1, 2. 2 plus 1, 3. How many 2 do you have in 3? You still have 1, remainder 1. So you have 1, remainder 1. Bring down the 1. So you can see this is in this. So this continues. Whether you are adding, whether you are subtracting, whether you are multiplying and dividing, the same method applies. So let's quickly solve a question now. Let's quickly solve the question. Let's solve a question. Let's start with binary number. Let's say we are to multiply this binary number 10 times 10. What do we do? In base 2. Base 2. 0 times 0, 0. 0 times 1, 0. 1 times 0, 0. 1 times 1, 1. How we add? 0 plus nothing, we have 0. 0. So this number is 10 base 2. So that is the addition. Okay, now if we are to multiply this number now, it's 2, it's 2. What do we do? 1 times 1 is 1. 1 times 1 is 1. 1, 1. We are finished with 1. So now here. 1 times 1, 1. 1 times 1, 1. 1 times 1, 1. Now finish this 2. Now 1 times 1, 1. 1 times 1, 1. And then 1 times the last one, 1. Let's add. 1 plus nothing, have 1. 1 plus 1 is 2. 2 in base 2. We don't have 2 in base 2. So how many 2 do we have in 2? We have what? How many 2s? We have 0. Remember 1. So we write down 0. Sorry, 1 remember 0. So 1 plus 1, 2 plus 1. 1 plus 1 is 2. Then we don't have 2. We have 10. So 1 plus 1 is 10. 10 plus 1 is 11. 11 plus 1 is 100. So 100 we have 100. We are going to split it into this, and this. Right? So we write first one 0, the next one 0, the last one 1. That's how we go. So we now have 0 plus 1, 1, plus 1, 10. Now 10 we are going to split it into 2. We have 0 and 1. Let's continue. Let's continue. So we have 1 plus 1, which is 2. Remember we have two bunch of numbers here. So 1 plus 1 is 2. 2 plus 1, sorry, 1 plus 1 is 10. 10 plus 1 is 11. 11 plus 1 is 100. So we have 100 in this. So that is the addition. So now let's quickly discuss about decimal multiplication. If we are to multiply, let's say this number times 36 in base 9, what will it become? Now, 6 times 7 is 42. 42 is more than 9, because base 9 numbers have to be from 0 to 9. So we have 42. What do we do? How many 9s are in 42? Well, how many 9s are in 42? A simple method is just go to your times table. 9 times 1, 9 times 2, 18 times 3, 21, 9 times 3, 27. Then 9 times 4, 36. 9 times 5 is 45. So you can see 45 is more than 42. Right? 45 is more than 42, so we can only take 9 times 4. So we have 49 plus what? 6. 4 times 9 is 36. 36 plus 6 is 42. Remember, we always write the remainder and take the number to the next one. Right? So we write the 6 and then this 4, we bring it here. Right? Let's continue. 6 times 1 is 6. Plus this one, which is 4. 6 plus 10 plus 4, which is 10. How many 9s do we have in 10? So we have 1 9 plus 1. So what do we write? Remember, write 1. And the other 1 9 we take it here. So we have 6 times 8 is 48. 48 plus 1 is 49. Do we have 49 in base 9? No. 49. We convert it. How many 9s do we have in 49? Then we're going to have 5 9s, plus 5 times 9 is 45. Then what is remaining to become 49 is just 4. So our remainder is 4. Remember, we always write the remainder 4. Then the bunch will have 5. So you bring down the 5 here. 5. You know, what are we adding 5 to? There is nothing. So we just bring down the 5. So we are done with 6. So now let's go to 3. 3 times 7 is 21. Do you have 21 in this 9? No. How many 9s can go into 21? We have 2. 2 9s. 2 9 times 2 is 18. What's remaining? Plus 3. So remainder 3. So we bring down the 3. We take the 2 to the next one. So we have 3 times 1 3 plus 2 5. Do we have 5 in base 9? Yes, we have 5. So we write it now. So 3 times 8 is 24. Do we have 24 in base 9? No. So what do we have? 24. How many 9s do we have 24? We have what? 2 9s, which is 9 times 2, 18. 18 plus 1 will give 24, 6. So remember, it's 6. So we bring our 6 here, and then our 2, we take it here. What are we adding to? Nothing. We bring it here. So we are done. So let's start. 6 plus what? Nothing. So we have 6. 1 plus 3 is 4. Then 5 plus 4 is 9. We don't have 9 in this 9. So what do we have? 9. How many 9 do we have in 9? We have just 1 here, 0. We write 0, we write 1 here. 5 plus 6, 11 plus 1, 12. Do you have 12 in this 9? No. How many 12? How many 9 can go into 12? 1, remember 3. Remember is first, then the 1 unity. 1 plus 2 is 3. So we have this our answer in base 9. I hope with this we are understanding what number bases are. So now, this multiplication of number bases. So what about when we are dividing? When we are dividing, of course, division of number base is very, very confusing. But one has to be very, very careful when performing some of this discussion. One has to be very, very careful. Now let's assume we are dividing in binary numbers. Let's say we have numbers like 100, 100 to be divided by what? Together. Remember, it's a binary number. When we look at it, it's a binary number. Remember, we cannot have 2. So even if 100 divided by 11 is 9 or is 8, it is not possible because we cannot write it 8 because it is a binary number. So what do we do? Remember, if 11 must go into 100, it must go either 1 and 0, or 2 and 0, or 1 and 0, or 0 and 1, something like that, or 1 and 1. You understand? So now first of all, let's write the first 2-digit number. 11 into 100, you know you cannot. So 11 into 10 divided by 11, you can only say 100 divided by 11. 100 divided by 11. Now remember, because 100 divided by 11 is 8. In fact, it's 9. We're giving us 99. So 100 divided by 11 can be 9. Right? So then we cannot have 9 in binary. So what do we have? First of all, we don't have 9. We have only 1. 1 times 11. Because we divide 100 to 11, so we have 11. When we subtract, what do we have? 0 minus 1 cannot. What do? You go to the next bit. You go. The next bit is 0. You cannot borrow 1 from 0. You can only borrow from 1. So let's borrow 1. What are we borrowing? We borrow 1. But it's the numbers in this 2. And when we are borrowing, we can only borrow what? 1. Right? When we borrow, it becomes what? Let's keep borrowing. When we borrow what? We borrow 1 from here and add to it. It becomes what? 10. Right? This one becomes what? 10. Okay? Now, 10. We borrow 1 again from 10. It left with what? 1. Why is it left with 1? We bring the 1 here. Why is it left with 1? Remember, 1 plus 1 in base 2 is equal to 10. So if you borrow any 1 from here, what's remaining will be 1. So let's bring that. So this one becomes 1. 1 minus 1 is 0. Here is what? Here, remember here, it became 10. When you borrow 1 from 10, it became what? Left 1. Here it is 0. So 10 minus 1 minus 1, 10 minus 1, sorry. 10 minus 1, sorry. This one will borrow 1 from here and actually here becomes 10. 10 minus 1, 1. Here becomes 1 minus 1, which is 0. Please, do you understand? Now let me go back again. Let me go back again. Remember, we said we cannot have 2 in binary. We can only have 1 and 0. So we say 100 divided by 11 is 9. We cannot have that. So we can only say 1. 100, 11 goes into 100 once. 1 times 11, 11. Now, we have to borrow. 0 minus 1 cannot. We have to borrow only from this guy. We borrow 1 from this guy and add it here. It becomes what? 10. It's the last digit number of it. So we borrow 1 from 10. When you borrow 1 from 10, 10 here becomes what? 1. The 1 we borrow, you add it here becomes 10. 10 minus 1, 1. Because you cannot have 9. 10, because 1 plus 1 is 10. So 10 minus 1 is 1. Here you have just 1. 1 minus 1, 0. You bring down the 1. 0. 11 divided by 11 is 1. Add the 2 0. 100 times 11 plus subtract. We're going to have 0 all. So we can see that 1 0 0 1 0 0 in base 2 divided by 11 in base 2 is equal to what? Equal to what? 1 1 0 0 base 2. So it is how to perform this. Now the last thing we are going to discuss before we complete is in hexadecimal number. Supposing we have numbers in this form for 8 A B plus 2 C 3. When we see AB, it tells you that this is hexadecimal number C. So first of all, we need to arrange it. 48 AB, 3 C 2. Let's add. Now, what is B? B means what? 11. 11 minus 3 is 8. Sorry, is plus. 11 plus 3, sorry. 11 plus 3 is 14. Do we write 14? Do we write 14? 11 plus 3 is 14. What is 14? 14 is E. So we write E here. A plus C. A means 10. C means what? 12. 10 plus 12 is 22. 22, let's say this number is in base 16. Do you have 22 in base 16? No. How many 16 goes into 22? How many 16 goes into 22? We have 1 16 plus 6. Remember, we write remainder. then 1 here. 8 plus 2 is 10. 10 plus 1, which is 11. 11 is what? Right over here. So, what is remaining? What is remaining? So, what is remaining is just our 4. Our 4. So, this is how to perform calculation. So, on our next tutorial class, we are going to be bringing different solutions on how to solve any particular problem in binary. We're going to see, we're going to be given some binary numbers that are unknown, and we're going to ask to calculate any unknown formula, any unknown value of the unknown there. So, first of all, before we conclude the class, I would like to give you guys an assignment, and that assignment question, we are going to solve that due to correction next week. So I want you guys to solve this question for me. We're going to have 9b 4 3 minus 8ac. So that is our assignment question. 9b 4 3 minus 8ac. So thank you very much. This is Jetstream tutorial. So from time to time we are going to be having classes on different topics in mathematics. Today we just started with number system. So on our next discussion we are going to be solving problems in number system. And I bet you join us, and as a promise that your life in aspect of calculation or mathematics will not remain the same. So from this end here, we say good afternoon to you all. Thank you very much.